Shape is 1-year-old company, Finnish company, established June 2013 after a 1-year long research project, APCA, Automatic Corridor Clearness Analysis. There were several Finnish power companies and Finnish Geodetic Institute, which has 20 years experience with LiDAR scanning and the most referenced research company in industry. So, Shopper and the ACCA project was created because power companies wanted to know if is it possible when we fly with helicopter with LiDAR scanner, it's possible to fully automatically detect all the conductors, all the poles, each individual tree, and run business rules against those. For example, see each individual tree that can fall to the power lines, or with growth model when tree will grow so large that it will threaten the power lines. So after 1 year and 100,000 lines of Java code, the result was that it is possible, and because of that, we established the company. And the Shape's main product is this APCA service with fully automatic LiDAR analysis. We just put the raw point cloud in with customers' network information system data, and it automatically detects each individual conductor and all the trees and such. And last year, Shape analyzed 10,000 kilometers of mid-voltage network, distribution network. It was quite a challenge because we got the data in November, and during December we got the production going, and I had the production finished at the 30th of December, and I had 1 day to deliver the product, but we managed to do that. So, after we had analyzed the 10,000 kilometers of voltage of power lines, there were hundreds of thousands of issues, trees that were too close to the power lines and such. So it became a problem that not all of them can be managed this year, and you cannot just treat one tree there and one there. You have to group them into manageable areas that where power companies can do their maintenance work. So, and for power companies, the data itself doesn't have any value. Only better decisions made from that data has value. In layman's terms, the customer only wants to know which power lines he should maintain this year. He isn't interested at all about the data, it's just a cost on hard drive. He wants to do what he should do, and for that he used FME. So we created software maintenance product to prioritize and visualize vegetation observations and create ready vegetation management plans and work orders that the power companies can send to the actual guys who cut down the trees. So, first of all, it's a problem because FME doesn't have this kind of transformer off the bat. So I started experimenting. I just used the neighborhood aggregator to create some kind of areas which are reasonably sized, so you could do maintenance work there. And then I noticed that it didn't really work because some of the areas had a lot of issues here and a lot of here and nothing between. So I had to create some rules that cut those to 2 different areas, and sometimes there were 2 areas that had a lot of next to each other, and I combined those, and after a few hundred transformers it was pretty okay. But also we had to test how good this was. So we compared it against, we tried to find out how many issues there were per kilometer of power line. So we first took the worst customer area, like maintenance areas that they have, and calculated how many issues there are per kilometer, and then compared it against how many issues there are in the worst area that we created dynamically. And our areas had roughly 2 times more issues, so it was really a good result, and 5 times more issues than average on network. So it's and this information enables need-based vegetation management. That you just you don't have to walk around whole 10,000 kilometers of power line and look if there is some issues and fix them. With this, you can prioritize and pinpoint where you should go. Try to show you. Yes, one of our customers wanted to do helicopter cutting. It's huge chainsaw attached to the helicopter. Oh.
Switch back on.
Okay.
Yeah.
Okay. Yeah. One of our customers wanted to do the helicopter cutting with using these dynamic areas that we have created. So it's basically 5-meter long chainsaw attached to helicopter. So these are the areas that they will actually do with helicopter cutting this year. So and we've given them in PDF form because PDF is something that everyone can open and they can send it to contractors who want that sophisticated technology. So.
Do you want me to set it here?
Yeah, maybe that's better. Sorry, everyone.
Technical difficulties.
Yes, but in last year we delivered our results with PDF, but this year we are already changed to the cloud services and provide everything with cloud. And also, if they want to have the old PDF, they can just export them using the cloud service. And yeah.
Leave that up
Yeah. Okay. And also, I put your links to those areas so I can get better resolution and see each individual issue that there is. The green ones are like minor issues, orange ones are worse issues, and red ones are ones that should be maintained very fast. And the ones that are in the blue are the ones that they should fly with helicopter this year, and black ones have so few issues that those should be skipped because they aren't that important. Yep. And why I love FME is because it's very fast, and I'm not only talking about performance. FME is very good transforming ideas into workspaces very quickly. So it's perfect for fulfilling small specific needs that our customers have. For example, one customer wanted to have cross-section images of power lines and line profiles as an image format that they can attach to their network information system objects. So they asked, can we do that? And after half an hour of doing stuff, yeah, I did. So they want to have something like this. So after half an hour of doing stuff, we sent them, is this okay? And they said, okay, yeah, that's fine. So this is not an image, this is actually a point cloud clip, but we just transformed into image, but that's trivial. And the other one. Yeah. Yes, yeah, this kind of image of flying profile. And here you see line that crosses the high voltage power line, and it's mandatory by law to Finnish power companies to know if there is a crossing of that kind of lines, and they also need to have this kind of imagery of that. So that's why they want to have this and be provided. And also they can see underground road from these, and this can be easily, when there are images, they can easily send to the contractors and such. If I saw it from here,
Control F5.
yeah.
F5.
And also all data conversions that we do, we use FME from customer system data format to our format, and backwards there. So we are using XML as a changing tool there, and yeah. And other things that we are now doing, that ESA, European Space Agency, selected sharper shape for studying how satellite data could be used to help power distribution companies in their asset management or maintenance work. How it could help. Because satellite data has a lot less resolution than LiDAR data. We couldn't use the same kind of analysis. So we needed to figure out new methods to use. And one thing that we already heard today, I think, was with the hexagon presentation. We also create a change raster between two periods of time that can detect change either in color or elevation changes that has happened around. And from that we can see, for example, if there has been clear cutting, and if there has been clear cutting near power lines, it might leave some individual trees there, and those might threaten the power lines in the future. But also you can check if the maintenance work has been done correctly, because if some area you should have, the contractor should have cut all the trees down, and the satellite data shows that no change in elevation has happened, it means that the contractor hasn't done their work properly. And other kind of business tools we also use that. Example. So. Yeah. I can grab that one. Yeah.
Mind of its own.
Here, for example, this is like old image, and here is a new one. And from here, if there has been some kind of change in color of green, we can determine that there might have been some changes in vegetation, and that we change the polygons, and if these polygons interfere with the power lines that might cause some kind of alert, trigger to go find out what has happened. Also, other things that we are currently doing with FME is doing as a company is that we are studying use of UAVs as a platform to provide the LiDAR scanning, mainly because UAVs are a lot cheaper to fly than helicopters. And one thing that we are using FME for that is planning the routes that UAVs will fly, because they have limited flight range, so they can fly indefinitely. So we find out the best routes using FME path algorithms and use that to optimize our processes. And other things that we are doing is, because now we are using Amazon Cloud Services to provide our customers this information, we are also planning to change to FME server, mainly to FME Cloud, as a plugin to these kind of small issues that customers have and better help our work flow. In future, we are planning to change it so that all this analysis of data is done in real time, and when we fly with a helicopter or UAV, the data is analyzed and sent to the cloud in real time, and the power companies can immediately see if there is a threat, and for example, after storm, if there is a freeze falling to power lines, then we can immediately do some work for that. So yes, thank you.
That was a little technically challenging there to explain why you're going on. Honestly, I guess the PowerPoint was driving that a little bit on. Does anybody have any questions?
When you're,
Okay,
you go first.
sorry,
Do you collect weather information when you fly in a helicopter?
Currently we don't.
So, like the sag and the line, how do you know if it's really, if a tree is within a violation or not? Is it as built essentially that you're comparing against, or?
There are like rules. For example, the corridor should be in mid of this network 10 meters wide. So if there is some branches inside the 10 meters, they shouldn't be there and should be maintained or removed.
Do you do any follow-ins?
This is also used as a way to our companies to check if the contractors have done their job. For one area that they have done the maintenance work, if there is some issues detected there, that those are like insurance jobs that the contractor must do now for free because they shouldn't be there.
yeah, good question on the SAG, because I'm sure we'll reach back.
Are those slides going to be available for us?
These slides?
Yes, they will be after the
Yeah,
conference.
they'll be available.
Yeah.
And then we had,
I was just asking about the polygon change is quite interesting, and like when you use the rasters to see what has changed.
Yes.
But how big? Like, so what is your tolerance? Do you say like when there's X amount of pixels, we look at it?
Yeah, there is some threshold area. How big it should be, and also we check if the like old or new image has something fishy about it. If it seems that other image has some wrong data, then we just discard that one. But the areas has to be big enough that they are big as light change.
anyone else?
Your change detection, that was Erdos as you used? And comparing
That was all
that
of
to
the
the raster imagery.
Yes.
That's Erdos? Software product.
No, we just use FME.
Oh, really?
It's just if I could show it, yeah, actually. was just
That image right there, what decided what pixels to turn blue?
yeah.
Dragging the workspace over.
Yeah.
Okay.
No, it's actually the wrong one. It's just an evaluator. So I calculate that here is the new one and here is the old one, and I just calculate the differences using this just the expression evaluator against each other. So if there is some, the numbers are just empirically, they seem quite good values, and using those I just notice that there has been change.
Great. Anybody else?
Did you do any sort of classification to that vegetation or terms for vegetation? Because
Yeah, actually, we don't classify point clouds at all. We connect points to the real-world objects. So we say that this point is connected to this tree, and that tree has a name. This has very useful. For example, if contractor removes one tree, we can just say that this tree has been removed, and all the points that were connected to that tree are removed. And also we can color each individual real-world object with the color we want.
so the power companies then didn't want any sort of information of how to manage the vegetation, like they didn't have any information with the vegetation itself, because they're going to have different types of way of managing different types of vegetation. They didn't want any sort of like volumes or densities of
They also want that. We also provide like how much tree there is that they will remove and how much money they will get if they sell that tree, and that kind of information. We also provide that. Yes.
How big is that raster? Because if you're looking at an individual tree versus a clump of trees, just thinking about how big that raster size, cell size is.
Yeah, that is a problem. That's why there is a research project to find out if there is a way to get free or cheap data that is good enough to find out that information. So.
Okay, anyone else? I have one last question. You mentioned in the beginning, I might have missed something, for a lot of Java code.
Yes.
Were you using FME then, or was it after that you decided to go there?
Because after that, I joined the company in September, and before that, the content recognition of the objects had been done, and that had been done with Java. But all the prioritization and small works we do with FME, and also after that we have done some like conductor recognition stuff with FME in Hypertext.
All right, thank you again.